Okay, y'all, so we're really quickly going to go over this monopolistic competition firm kind of worksheet that I created. So here you can obviously see we have our market here, which is a chair market, and so we have our demand curve in blue, our marginal revenue curve in black, our marginal cost curve in black, and then we've got three different average cost curves: our average total cost 1, average total cost 2, and average variable cost. So that's in red, orange, and green. So then I've also went ahead and put numbers for different types of prices and costs on our y-axis, and then also quantities on our x-axis. So the first thing we want to determine when we get this kind of graph is what is the profit maximizing condition. So the profit maximizing condition, this is something that you definitely need to remember for the test and just need to memorize it. That is marginal revenue equals marginal cost. So that's the first thing we need to identify on this graph. So marginal revenue equals marginal cost at this point right here. So you can see here, I just marked it. Let me mark it in pink. So we have that clearly marked again. We have that in pink. So that's our marginal cost curve swooping down, and then it's intersecting our marginal revenue curve right there. And so the profit maximizing condition, marginal revenue equals marginal cost, that tells us we have a quantity we want to drop straight down. We have a quantity of 100 as our profit maximizing quantity. So profit maximizing quantity is 100 here. Okay, so again, do you remember the story of the sidewalk? I told y'all to stay on the sidewalk when you're doing one of these graphs, whether that be for perfect competition, monopolistic competition, or for Monopoly that we'll do later on in another chapter. But we want to stay on this sidewalk, up and down. We don't want to get off the sidewalk. We don't want to go around the corner, remember? And so at this point, remember, we want to use the demand curve to determine our price for monopolistic competition. So staying on the sidewalk, we were at, let me go back. We were at 100. Now we're going to move up till we hit the demand curve in blue, which is here at this point right here. And then we want to go straight over to 15 right here. So our price at our profit maximizing condition is going to be $15. Okay. So we've got the quantity and now we've got the price. So now if I asked you to calculate what average total cost per unit is using average total cost 1, we would still go back again to the profit maximizing quantity 100 using the sidewalk, go straight up till we hit our average total cost curve number 1 in red, and then go straight over, and we have an average total cost per unit at the profit maximizing condition of 20. So ATC per unit at ATC 1 equals $20. Okay, so now if I asked you to calculate ATC per unit using average total cost curve number 2, which is in orange, again, we'd still use the same sidewalk and we'd go straight up till we hit the orange curve, which is there, and that's at 10. So our ATC per unit at the second average total cost curve is 10. So what I'm doing here is I'm just showing you two different average total cost curves. This is kind of simulating if average total cost were to decrease over time, what would essentially happen in this market. So now let's calculate total cost using both of those per unit costs we've just determined. So our total cost at average total cost curve 1 using our profit maximizing quantity of 100 would be, you would multiply 100, our quantity, times 20 equals 2,000. Okay, so now we would go to the average total cost per unit for the second curve, and we'd still use the same 100 chairs as our profit maximizing quantity, so it'd be 100 times 10. So we have 1,000 as our total cost using the average total cost curve 2. Okay, So now if I were to ask you to use variable cost per unit, again, going back to our sidewalk, going back to our diagram up here, we would identify here, use the sidewalk to go straight up till we hit the green average variable cost curve at 5. So our average variable cost per chair per unit equals $5. Okay. So now let's calculate our total variable cost at the profit maximizing condition, which would be 100, our quantity, times $5 equals 500. Okay. So now if I was to ask you to calculate total fixed cost, remember our formula to calculate total cost or average total cost was average total cost equals made up of two components, average fixed cost plus average variable cost. So now we already know what our average total cost per unit is. We already know what our average variable cost per unit is. So then we're able to calculate what our total cost is, our fixed cost, and we already know what our variable cost is. So if I was asking you to calculate total fixed cost at average total cost number 1 and average total cost number 2, what we'd need to do is we would need to subtract our total cost at each of those from we would need to subtract our variable cost from the total cost. So we need to first calculate total cost and then subtract off variable cost. So what we would do, I'm just going to go over here and do it just to give myself a little bit more room. Okay, so average fixed cost per unit at using is take the average total cost at each point and then subtract the average variable cost that we found. So we already know what the total cost is at ATC1 and ATC2, which we've got that already just done here. And then we also know our total variable cost, which is 500. So to find total fixed cost at those 2 points, essentially using those 2 average total cost curves, what we would need to do is take 2,000 minus 500 equals 1,500. And we would also take 1,000 minus 500 to equal 500. And then that would be your total fixed cost at ATC1 and your total fixed cost at ATC2. Okay. And then finally, the last thing I would ask is to calculate profit or loss at both average total cost 1 and average total cost 2. So in order to calculate the profit or loss, we need to think back and remember the price. So in order to calculate the actual amount of total revenue we had, remember the formula for total revenue equals total revenue is quantity times price. So at our profit maximizing quantity of 100 times our price of $15, we would have a total revenue of $1,500 equals total revenue. And so to calculate profit or loss, we would just need to take our total revenue minus our total cost at each point. Total revenue minus total cost. So total revenue for both situations would be $1,500. And then our total cost at average total cost 1 would be the 2,000 we determined earlier. And at ATC 2, it would be the 1,000. Therefore, we're going to have a loss of 500 at ATC 1 and a profit of 500 at ATC2. So here, let me just quickly, I want to mark our answers in yellow highlighter so we can see. So our profit maximizing condition is our MR equals MC. Then we've got our profit maximizing quantity, which is that $100 chairs, my bad. And then we have our price, which we used the demand curve to find the price of $15. ATC per unit at using ATC1 is $20. ATC per unit using ATC2 is $10. Total cost using ATC1 is $2,000. Total cost using ATC2 is $1,000. Average variable cost per unit is $5 using the green curve. And then we had our total variable cost, which was our 100 chairs times the average variable cost per unit of $5 equals $500. And then we used the previously calculated average total cost and average variable cost to determine the average fixed cost and essentially the total fixed cost at both of those curves. And then finally, we calculated whether or not there would be a profit or a loss. As you can see, if ATC is above our price, we suffer a loss. And if ATC is below our price, we actually experience a profit.